temporary power pole should not pass inspection and be energized if not installed by a qualified electrical contractor for several reasons. Firstly, safety concerns. Temporary power poles are typically used for short-term projects and aren't designed to meet the same safety standards as permanent poles. They might not be properly grounded or secured, which could create a hazard for workers and the public. Secondly, code violations. Most building codes have specific requirements for the installation of temporary power poles. These requirements may include the use of specific materials, the placement of the pole, and the type of electrical equipment that can be used. Thirdly, liability. If an accident occurs due to a faulty temporary power pole, the contractor who installed the pole could be held liable. The fact that the temporary power pole has been in place and energized for a year now doesn't make it safe or compliant with code. It's important to have the pole inspected by a qualified electrical contractor and have it replaced or repaired if necessary. The National Electrical Code, or NEC, sets standards for electrical installations to ensure safety. Temporary power installations, while intended to be short-term, must still adhere to these standards to minimize risks. Grounding is a critical aspect of any electrical system. Proper grounding provides a path for fault current to return to the source, tripping a circuit breaker or fuse and preventing electrical shock hazards. Temporary power poles must have a properly installed grounding electrode system, which typically involves driving ground rods into the earth and connecting them to the pole's grounding bus. The size and number of ground rods required depend on the soil resistivity and local code requirements. Bonding is another essential safety measure. Bonding involves connecting all metal parts of the electrical system together, including enclosures, conduits, and equipment grounding conductors. This creates a low impedance path for fault current, ensuring that all metal parts are at the same potential, minimizing the risk of electric shock. Temporary power poles must have all metal parts properly bonded together. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. Temporary power poles must have properly sized overcurrent protection devices for all circuits. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock. GFCIs monitor the current flowing in the hot and neutral conductors of a circuit. If there's a difference in current, it indicates that current is leaking to ground, potentially through a person. The GFCI trips the circuit, interrupting the flow of electricity and preventing serious injury. Temporary power poles used in wet or damp locations must have GFCI protection for all receptacles. Wiring methods used for temporary power installations must be appropriate for the environment and the type of equipment being used. Cables must be protected from physical damage, and connections must be made in approved enclosures. The NEC specifies the types of wiring methods that are permitted for temporary installations. Clearances are also important. Temporary power poles must be located so that they maintain safe clearances from buildings, trees, and other obstructions. The NEC specifies minimum clearance distances for different voltage levels. Inspections are crucial for ensuring that temporary power installations are safe and compliant with code. A qualified electrical inspector will examine the installation to verify that it meets all applicable requirements. Any deficiencies must be corrected before the installation is energized. Regular maintenance is also important. Temporary power poles should be inspected regularly to check for damage, loose connections, and other potential problems. Any issues should be addressed promptly to maintain safety and prevent accidents. Qualified electrical contractors have the training and experience necessary to install temporary power poles safely and in compliance with code. They understand the relevant regulations and know how to properly ground, bond, and protect the installation. Hiring a qualified contractor is essential for ensuring that the temporary power pole is safe and reliable. When a temporary power pole is installed, there's a need to know the applicable codes and standards. The NEC is the primary source of requirements for electrical installations in the United States. Article 590 of the NEC specifically covers temporary installations. Local codes may also have additional requirements. Adherence to these codes and standards is essential for ensuring safety and compliance. It is important to select the proper location for the temporary power pole. The pole should be located in an area that is accessible for maintenance and inspection, and it should be protected from damage. It should also be located away from areas where people are likely to come into contact with it. Proper grounding is critical for safety. The grounding system should be installed in accordance with NEC requirements. This typically involves driving ground rods into the earth and connecting them to the pole's grounding bus. The size and number of ground rods required depend on the soil resistivity and local code requirements. The equipment grounding conductor, or EG, is used to connect the metal parts of the electrical system together. This provides a low impedance path for fault current, which helps to protect people from electric shock. The EGC should be sized in accordance with NEC Table 250.122, based on the rating of the overcurrent protection device. Overcurrent protection is required for all circuits. Circuit breakers and fuses are used to protect circuits from overloads and short circuits. The overcurrent protection devices should be sized in accordance with NEC Article 240. Ground fault protection is required for receptacles that are used in wet or damp locations. GFCIs are used to protect people from electric shock. GFCIs monitor the current flowing in the hot and neutral conductors of a circuit. If there is a difference in current, it indicates that current is leaking to ground, potentially through a person. The GFCI trips the circuit, interrupting the flow of electricity and preventing serious injury. Wiring methods used for temporary power installations must be appropriate for the environment and the type of equipment being used. Cables must be protected from physical damage, and connections must be made in approved enclosures. The NEC specifies the types of wiring methods that are permitted for temporary installations. Clearances are also important. Temporary power poles must be located so that they maintain safe clearances from buildings, trees, and other obstructions. The NEC specifies minimum clearance distances for different voltage levels. Inspections are crucial for ensuring that temporary power installations are safe and compliant with code. A qualified electrical inspector will examine the installation to verify that it meets all applicable requirements. Any deficiencies must be corrected before the installation is energized. Regular maintenance is also important. Temporary power poles should be inspected regularly to check for damage, loose connections, and other potential problems. Any issues should be addressed promptly to maintain safety and prevent accidents. Qualified electrical contractors have the training and experience necessary to install temporary power poles safely and in compliance with code. They understand the relevant regulations and know how to properly ground, bond, and protect the installation. Hiring a qualified contractor is essential for ensuring that the temporary power pole is safe and reliable. Temporary power installations are typically fed from a utility transformer. The transformer steps down the high voltage electricity from the utility grid to a low voltage that can be used by electrical equipment. The transformer should be properly sized for the load that it will be serving. The service entrance conductors are used to connect the transformer to the temporary power pole. The service entrance conductors should be sized in accordance with NEC Article 310. The service disconnecting means is used to disconnect the temporary power pole from the power source. The service disconnecting means should be readily accessible and should be capable of being locked in the open position. Distribution panels are used to distribute power to the various circuits on the temporary power pole. The distribution panels should be properly sized for the load that they will be serving. Branch circuits are used to connect the distribution panels to the individual loads. The branch circuit should be sized in accordance with NEC Article 210. Receptacles are used to provide a convenient way to connect electrical equipment to the temporary power pole. The receptacle should be properly grounded and should be GFCI protected if required. Lighting is often required for temporary power installations. The lighting should be properly installed and should be protected from damage. The NEC contains specific requirements for temporary lighting installations. The temporary power pole should be clearly labeled with the voltage and amperage of the electrical system. The labeling should be durable and should be readily visible. All electrical equipment used in a temporary power installation should be listed by a recognized testing laboratory, such as Underwriters Laboratories, or all. Listing indicates that the equipment has been tested and meets safety standards. The temporary power pole should be inspected regularly to ensure that it is in good condition and that it is operating safely. Any damage or defect should be repaired promptly. The temporary power pole should be removed when it is no longer needed. The removal should be done safely and in accordance with all applicable codes and regulations. The installation of a temporary power pole involves several steps and considerations. Firstly, planning and preparation. Before installing a temporary power pole, it's crucial to plan the installation carefully. This involves determining the location of the pole, the loads that it will serve, and the applicable codes and regulations. Secondly, obtaining permits. In many jurisdictions, a permit is required to install a temporary power pole. The permit application typically requires detailed information about the installation, including drawings and specifications. Thirdly, site preparation. The site where the temporary power pole will be installed needs to be prepared properly. This may involve clearing vegetation, leveling the ground, and installing a temporary foundation. Fourthly, pole installation. The temporary power pole is typically installed using a crane or other lifting equipment. The pole must be properly aligned and secured to the foundation. Fifthly, grounding system installation. The grounding system is a critical safety feature of the temporary power pole. The grounding system must be installed in accordance with NEC requirements. Sixthly, wiring and connections. The wiring and connections for the temporary power pole must be made carefully and in accordance with NEC requirements. All connections must be tight and secure. Seventhly, inspection and testing. After the temporary power pole is installed, it must be inspected and tested by a qualified electrical inspector. The inspector will verify that the installation meets all applicable codes and regulations. Eighthly, energizing the installation. Once the temporary power pole has passed inspection, it can be energized. Only qualified personnel should energize the installation. Ninthly, maintenance and monitoring. The temporary power pole should be inspected and maintained regularly. Any damage or defect should be repaired promptly. Tenthly, removal. When the temporary power pole is no longer needed, it should be removed safely and in accordance with all applicable codes and regulations. Regarding the electrical system components, the service entrance conductors carry power from the utility transformer to the main disconnect of the temporary power installation. Their size must be calculated based on the total load and comply with NEC ampacity tables, considering factors like conductor, insulation type, and installation method. The main disconnect switch provides a means to shut off all power to the temporary installation. It must be readily accessible and rated to interrupt the maximum available fault current. Subpanels distribute power to individual branch circuits. They contain overcurrent protection devices like circuit breakers or fuses to protect each circuit from overloads and short circuits. The number and size of subpanels depend on the number of circuits needed. Branch circuits supply power to specific loads, such as lighting, receptacles, or equipment. They must be protected by overcurrent devices sized according to the load and conductor ampacity. Grounding electrodes, such as ground rods or plates, provide a connection to earth, ensuring a low impedance path for fault currents. The type and number of grounding electrodes depend on soil conditions and NEC requirements. The equipment grounding conductor connects the metal enclosures of electrical equipment to the grounding system, providing a path for fault currents to return to the source and trip the overcurrent device. Ground fault circuit interrupters protect personnel from electric shock by detecting small leakage currents to ground and quickly interrupting the circuit. They are required in wet or damp locations and for certain types of equipment. Receptacles provide a convenient means of connecting portable equipment to the power supply. They must be properly grounded and, in some cases, GFCI protected. Luminaires provide illumination for the temporary work area. They must be installed safely and protected from physical damage. Wiring methods used for temporary installations must be suitable for the environment and comply with NEC requirements. Common wiring methods include cable assemblies, flexible cords, and conduit. The electrical boxes and enclosures protect wiring connections and provide a safe enclosure for electrical components. They must be properly sized and installed. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical circuits from overloads and short circuits. They must be sized according to the load and conductor ampacity. Surge protective devices, or SPDs, protect electrical equipment from voltage surges caused by lightning or other transient events. They are often used in temporary installations to protect sensitive equipment. Finally, labels and signage identify electrical components and provide safety information. They must be durable and readily visible. A temporary power distribution system design should take into account load calculations to determine the total demand for power. This involves estimating the power requirements of all equipment and devices that will be connected to the system. Voltage drop calculations ensure that the voltage at the farthest point in the circuit remains within acceptable limits. Excessive voltage drop can cause equipment to malfunction. Short circuit calculations determine the maximum fault current that could flow in the event of a short circuit. This information is used to select overcurrent protection devices with adequate interrupting ratings. Coordination studies ensure that overcurrent protection devices operate in a coordinated manner, minimizing the extent of a fault. Arc flash hazard analysis identifies potential arc flash hazards and determines the appropriate personal protective equipment, or PPE, requirements. Single-line diagrams provide a graphical representation of the electrical system, showing the components and their interconnections. Bill of materials lists all the materials required for the installation. The temporary power distribution system installation requires qualified personnel, including licensed electricians, are responsible for installing and maintaining the system. Proper safety procedures, including lockout/tagout procedures, must be followed to prevent accidents. Regular inspections and testing are essential to ensure that the system is operating safely and reliably. Documentation, including drawings, calculations, and inspection reports, should be maintained for the duration of the temporary installation. Temporary power distribution system operation includes proper grounding and bonding to minimize the risk of electric shock. Overcurrent protection devices should be sized and coordinated to protect equipment and personnel. Ground fault protection should be provided in wet or damp locations and for certain types of equipment. Regular inspections and testing should be performed to ensure that the system is operating safely. Any problems should be addressed promptly. The temporary power distribution system maintenance requires regular inspections to identify any potential problems, such as loose connections, damaged wiring, or malfunctioning equipment. Testing should be performed to verify the proper operation of overcurrent protection devices and ground fault protection. Any repairs or replacement should be performed by qualified personnel. Documentation of maintenance activity should be maintained. Lastly, the temporary power distribution system decommissioning involves disconnecting the system from the power source, removing all wiring and equipment, restoring the site to its original condition, proper disposal of all materials, documentation of decommissioning activities. Remember to always consult with a qualified electrical contractor or engineer for specific guidance on temporary power installations.